Today, we're getting down to the nitty-gritty, the nuts and bolts, the very building blocks of our world, literally. We're talking about materials, what we use to build, and the techniques to, actually put it all together. It's architecture at its most fundamental.
Exactly. It's kind of back to basics, but when you think about it, it's also super profound. I mean, for anyone listening, whether you're dreaming of a kitchen remodel or walk by a skyscraper every day and wonder, how does that thing even stay up? Or just want to look at buildings with a more, informed eye, grasping these ideas of materials and construction, it's like getting a key to a whole new level of appreciation.
Totally. And we've really dug deep for this one, gathered a ton of different info. So we're going to pull out some stuff that'll make you go, huh, never thought of that. Maybe even some surprises along the way. Our mission here is pretty straightforward. We want to give you that shortcut to understanding like the core relationship between what buildings are made of and how they're actually, well, built. It's seeing how those choices, they impact everything, from the initial vibe you get when you walk into a building to its environmental impact over time and even, its cultural meaning.
Oh, for sure.
So let's get down to it. What do we even mean by materiality in the context of architecture? Because it sounds like a lot more than just a fancy way to say materials, right?
Yeah, you hit the nail on the head. Materiality is about like the whole experience of material. You got to think about its physical qualities. Like, is it heavy? Dense. Think of a big chunk of granite. Or is it super light and flexible, like, say, bamboo? Then you have how it hits our senses. Is it rough, smooth? What about a color? Vibrant. Or subtle texture? How does it play with light? Does it, like, bounce it all over or kind of suck it in?
So we're going beyond just what it looks like.
Yeah, beyond the visual, even beyond the touch. What about the sounds? Like, think about a wood floor, that creak, or even that kind of smell you get with certain types of wood. And then on top of all that, there's this whole layer of, like, cultural meaning and symbolism that materials can hold, like marble, right? In classic architecture, that's all about luxury, permanence. And of course, we got to factor in the environment these days. Where did this material come from? How much energy to process it? What happens to it when the building's done? So materiality, it ties that sensory stuff, the whole logic of how it's built, and the bigger picture environment, culture, history, everything that feeds into the building.
Wow, so much more to it than I originally thought. All right, so that's the stuff we build with. Can you give us a quick tour of the toolkit the palette architects get to play with?
Sure, we could break it down. First off, natural materials, straight from the earth or, nature's bounty. Timber, various stones, even earth itself, like you see in adobe or rammed earth construction. Bamboo, heck, even straw. Then you've got processed stuff. They start natural, but we, put them through the ringer. Brick, concrete, glass, all your steel, big players there. Then we got composites. That's where you're combining two or more materials to get, like, new properties. Think plywood, your laminated veneer, lumber, LVL, carbon fiber, and fiberglass. And more these days, it's all about recycled or upcycled stuff. Reclaimed wood, crushed brick, recycled plastic, even rubber's getting in on the action.
That's a pretty big range to work with. Each one probably has its own quirks, its own set of pluses and minuses.
Yeah.
You mentioned that choosing these materials, it's not just like picking your favorite color, is it?
Nope, not at all. Picking material, it's this whole decision-making web. Climate's a huge factor.
Yeah.
Like building an ice hotel in the tropics, not going to work out so well.
Yeah.
And of course, availability and cost, that's always going to be a reality check. But these days, sustainability, that's really driving a lot of choices.
Yeah.
Then you've got the cultural history of a place, what's been traditionally used, and at the end of the day, the building itself, how it needs to perform, how strong does it need to be, insulation needs, how well does it got to stand up to the elements, all that comes into play. So next time you're checking out a building, take a second and think, why those materials? It's usually a cool story there.
I like that. All right, so we've covered the what. Now for the how, the construction techniques. What all falls under that umbrella?
Okay, construction technique, that's all about how we take those separate materials and make them into a structure that, actually works. Starts with the structural system. Is it load-bearing walls, just stacking stuff up to hold the roof? Internal frame, maybe steel or timber, like a skeleton, or a shell, often concrete. You can get tensile systems, those lightweight kind of tent-like roofs where the material's held in tension. And then how do we stick it all together? You got mortar for bricks, welding for steel, all sorts of adhesives or mechanical connections, your bolts and screws and whatnot. Then there's the way stuff's made in the first place. Cast in molds, cut with machines, folded, extruded, and then the whole shebang of putting it all together on site, managing the whole construction process. That's a whole other beast.
And I imagine, just like with the material choices, the way it's all put together, that's going to have huge consequences.
Oh, absolutely. How it's built, that's going to impact the structural integrity, how well it handles all the forces and stresses. But it also kind of dictates the shapes, the kinds of spaces you can create, the cost of the whole project, how fast you can build it, and even how it looks in the end. Imagine a building with all this intricate timber joinery versus one made from those huge precast concrete panels. Totally different vibe.
Right, yeah, you see that.
Huge difference.
Okay, so it's a back and forth, the what and the how, all tangled up. Let's take a trip back in time now and see how these choices have evolved over history.
Early architecture, it was all about using what was around you. Forest, timber, lots of clay. You'd see adobe, abundant stone. You got it, stone masonry. And a lot of this was, elbow grease. Hand-shaped materials, knowledge passed down through generations, techniques adapted to the climate, the culture, the resources they had.
We've got some great examples from our research that really show this, right?
Oh yeah, for sure. Think of Great Zimbabwe, those huge walls, all dry stacked stone, no mortar. The skill to shape those stones, fit them together, it's mind-blowing. Or those traditional Japanese Minka houses. They used crazy sophisticated joinery, no nails needed. And then you've got igloos, simple but genius. Shaping those blocks of snow, that dome structure, surprisingly good at holding in heat.
Wow, yeah.
It really highlights that connection between people, place, materials. It was very direct.
Right. So what happened as societies got more, I guess, complex? Did things change?
Definitely. You start to see existing techniques getting refined and new materials come into play. Technology advances, trade expands, all that fuels the change. Ancient Greeks and Romans, they really upped the game with stone construction. They developed like sophisticated systems with columns, arches, and vaults. The Romans, they were particularly killer with concrete, allowed them to make these like groundbreaking shapes, like the Pantheon dome. Massive. Couldn't have done that with just stone at that scale.
Right.
Later on, medieval times, the folks building those Gothic cathedrals, they pushed stone even further.
Yeah.
Flying buttresses, ribbed vaults, all that. Those weren't just about building bigger. These innovations, they made those soaring heights, the huge stained glass windows, they made all that possible. That's what defined the Gothic style. Changed how people experienced space and light inside those buildings.
So these changes, it wasn't just about technology. It changed what architecture could be, how it felt to be inside it. And then the Industrial Revolution, that must have really shaken things up.
Totally. When mass-produced iron, steel, and then later those large sheets of glass hit the scene, it was a game changer. Suddenly you could build huge and fast train stations that stretched forever, bridges reaching across vast spaces, and eventually skyscrapers shooting up to the sky. That's when mass production and prefabrication took off, making building parts in factories, then putting them together on site. The Crystal Palace from the Great Exhibition in 1851, that's the poster child. This huge structure built in a flash using pre-made iron and glass pieces. It was like, bye-bye, traditional construction.
Yeah, that's wild. So it went from this handcrafted thing to like an industrial process. What about the 20th century? What were the big developments then?
20th century, more material innovations. And they really changed how architecture looked and felt. Reinforced concrete came along, allowed for those flowing sculptural design stuff that cantilevered out, think Le Corbusier, Oscar Niemeyer. Then steel framing, that became the backbone of the international style, those sleek glass walls, those open floor plans. And then you had brutalism, which was like, hey, let's just show concrete as it is, raw, exposed, celebrating how it's made.
Huh, interesting. So from those early days, shaping everything by hand, to these modern engineered materials, it's been quite a journey, huh? Driven by both like practicality, needing to solve problems, but also this push to do new stuff to see what's possible. Now, I'm super curious about this idea of like material as meaning, because clearly it goes way deeper than just, the physics of a brick or a steel beam.
Absolutely. When you get into the theory of materiality, it's about the deeper meaning of what we build with and how that changes how we experience buildings. There's this concept called the phenomenology of materiality. Folks like Peter Zumthor, Stephen Hall, Juhani Palasma, they've really explored this. It's all about how materials hit our senses and the emotions they stir up, not just the look, it's the feel, the sounds they make, even how warm or cool they are. Think about a room with rough wooden walls. Does it make you feel grounded, connected to nature, or maybe cozy, enclosed?
Yeah.
That's the kind of sensory experience this approach looks at. And then there's how light interacts with surfaces, the shadows, all that adds to the atmosphere.
So it's the whole package deal, what it looks like, feels like, sounds like.
Exactly. Zumthor said it perfectly. Materials in a building, they're not just there to do a job, they speak a language. And then there's this idea of material honesty, which was super important to a lot of modernist architects like Louis Kahn and Alvar Aalto. They believed you should use materials in a way that's true to what they are. Concrete should look and feel like concrete, not pretend to be something else. It's about being genuine, letting the material's character shine through.
I dig that. Let it be what it is.
Right on. And then there's cultural materiality, which recognizes that materials, they can embody regional identity, history, and cultural values. Think about how indigenous architects and those working in post-colonial contexts have often used local materials, kind of like a pushback against the dominant styles, which were often, imported. Francis Curé's work in Burkina Faso is a great example. He uses those compressed earth blocks from the local area. It's about connecting architecture to local resources, traditions, and sustainability.
It's powerful how a choice of material can hold so much weight culturally, tell a story about a place. Let's bring it back to the present now. What are the construction techniques we're seeing in contemporary architecture?
Today, it's a real mix, and each approach has its own perks. You've still got cast-in-place concrete, pouring it into formwork on the site. Tons of design freedom. You can get those flowing sculptural forms. Downside, it's labor-intensive, and concrete takes time to cure. Then there's precast concrete made in a factory, so you get speed, precision, high-quality control. It's often used for stuff like floors, beams, facade panels. Steel frame construction is still the king for skyscrapers and those long-span structures like bridges. Super strong, yet relatively lightweight.
And timber's making a comeback, right?
Big time. Engineered timber products like heavy timber, glelum, that's glued laminated timber, and CLT, cross-laminated timber, they're getting super popular. Renewable, they store carbon, and they're surprisingly strong. People might be shocked to see timber being used for, like, taller buildings these days. And then there's good old masonry, your brick, concrete block, stone. It's durable, fire resistant, and you get that tactile quality. It can be more labor intensive though. For those really dramatic lightweight structures, often temporary, like stadiums, pavilions, you see tension and membrane structures. And prefabrication, modular construction, that's getting more and more popular. Less waste, faster build times, and you can get some customization even within standardized units.
It's like construction's this cool blend of the tried and true and the cutting edge. What about the really futuristic stuff? What's happening on the bleeding edge of materials science and fabrication?
Oh man, that's where it gets really fun. We've got smart materials, things like glass that changes transparency depending on the temperature, or materials that store heat, got like thermal batteries helping regulate the temperature inside, even stuff that generates electricity when you put pressure on it. That's piezoelectric materials for you.
Wow, that's next level.
Totally. And then there's the explosion in bio-based materials, stuff made from like mushroom roots, algae, bioplastics. They can be insulation, structural parts, even facades. It's all biodegradable and regenerative, a real alternative to the conventional stuff.
That's so cool. It's like sci-fi becoming reality.
It kind of is.
Yeah.
And digital fabrication, things like CNC milling, laser cutting, 3D printing, they're changing the game. We can make crazy complex shapes, and everyone can customize stuff. Yeah. Look at firms like Zaha Hadid Architects or MAD Architects. Their designs are so visually striking, super intricate, and robots are showing up on construction sites now, doing stuff like laying bricks or assembling frames. Way more precise, efficient, safer, too. And with sustainability being so crucial these days, we're seeing a ton of innovation in recycled and upcycled materials. Plastic turning into bricks, tires into flooring, salvaged steel getting a second life. It's all about that circular economy.
So tech's really pushing the boundaries of what and how we can build. And you mentioned sustainability. That's got to be a major consideration for architecture these days, right?
It's the priority. The choices we make about materials and construction, they have a huge impact on a building's environmental footprint throughout its life. We're talking embodied energy. The total energy it takes to get those materials from the earth, process them, make them into building components, transport them, install them, and then there's operational energy. How much energy a building needs to run for heating, cooling, lighting, all that over its lifetime.
Right.
Indoor environmental quality, that's a biggie too. Thinking about things like VOCs, those nasty chemicals some materials release, and how materials affect things like comfort and moisture. And then, at the end of it all, what happens to the building? Can we reuse those materials, recycle them, or are they landfill bound?
Are there tools to help architects make these, environmentally responsible decisions?
Yeah, there are. There's something called life cycle assessment, LCA. It analyzes a product or building's environmental impact over its entire life, from cradle to grave. And then you've got environmental product declarations, EPDs, which give you standardized info about how specific materials perform environmentally. And there's a real focus these days on specific sustainable materials. Bamboo, it grows super fast, it's renewable, and it's strong. Recycled steel, you can reuse it over and over, it doesn't lose its strength. Reclaimed wood adds character, and it means we're not cutting down new trees. And there's this cool stuff called hempcrete, made from hemp herds and lime. It's a great insulator, and it actually pulls carbon dioxide out of the air.
Wow, that's incredible. So it's all about being informed and thinking about those long-term impacts. To really bring it all home, can we look at some examples of projects that are doing this cool stuff in the real world?
For sure. The Thurnvall Spa in Switzerland, designed by Peter Zumthor, is a materiality masterpiece. You use locally sourced quartzite, and it's both structural and decorative. It creates this incredible sense of place, a really tactile, timeless atmosphere. And then there's the Metropole Parasol in Seville by J. Mayer H. It's all about the potential of modern engineered timber. It's built from these laminated timber panels coated in polyurethane, and they were assembled using super precise modular components made with CNC machines. It shows how you can use timber to make these complex, engaging public spaces.
Are there examples that really showcase those sustainable principles?
Absolutely. The Center for Sustainable Landscapes at Fitz Conservatory in Pittsburgh, it was designed to be net zero energy and water. It uses recycled steel, FSC-certified wood, lots of natural light, prefabrication, and a green roof. And then you've got the ETH Zurich DFAB house. That's like the cutting edge of digital fabrication. Robots doing the building, 3D printed formwork for the concrete, lightweight concrete mixes. It's a glimpse into how AI and robotics could totally change construction.
Those examples are amazing. They really show how those material and construction choices can shape a building's character, how it works, everything. Thinking about the future now, what does all this mean for architectural education and how architects do their thing?
Well, it's clear that really understanding materials and construction, it's more crucial than ever for architects. In schools, we're seeing more hands-on learning, material testing, even students build what they design, so they get that intuitive grasp. Design build studios where they're involved in every step of the process, those are super valuable. And in the field, prototyping, making mock-ups, that's essential. You got to anticipate problems, work out the details. Architects need what you might call material literacy, understanding not just the looks, but the performance, the environmental impact, the cost, the cultural relevance. It's a lot to consider.
Yeah, it's a whole new level of awareness. So to wrap up, it's obvious that materiality and construction, it's not just technical stuff. It's at the core of architecture. How it works, how it shapes, how we experience space, how it affects the world around us.
Couldn't have said it better myself. Those fundamental choices we make, they reflect our technology, our values, our whole relationship with the environment.
I love that. So, to everyone listening, next time you're in a building, take a moment to really notice it. What materials do you see? What do they feel like? What's their story? How is it all put together? How does that affect your experience of the space? It's a whole new way to see the world around you.